Hello, everybody. We are the Acme Math Guys, and this is your 2022 Wish You a Very Mathematical Christmas math problem, math activity. I'm Clay Norton.
And I'm Alan Moret.
And here we go.
Okay, we know it's going to be very cold this Christmas, so you'll be looking for indoor activities to do. And what better activity is there than to get around the family table and work through some graphs? And I know, Coach Norton, you have graph paper with you all the time.
All the time. Keep it in my back pocket. You never know. You're on the run. Just you might need to pull out and work a problem. So I keep graph paper pretty handy.
Yeah, and plus your kids probably got some in their stocking for Christmas. So what a great way to get started with it. This is a little problem that we learned in North Mississippi from the infant school for mathematics.
Pre-K 4 or 3 was it?
Yeah, I don't remember. I was busy trying to derive equations and can't remember all that. So anyway, let's go along with this. So
what we're looking at is we're going to provide you with parabolic inequality, partial parabolic inequality functions.
That is correct.
To make a picture out of a graph.
Yes.
Trust us.
So we will start off with y is greater than or equal to negative 5/6 x squared plus 4. Now, I'm going to graph this based on 2 points in an intercept. First intercept is going to be the y-intercept, which is just the constant at the end of the inequality, which is going to be the point 0.04. The second one we get by letting our y-coordinate equal to 0. This will give us our x-intercept. So we get that 0 is equal to negative 5/6 x squared plus 4, which in turn becomes 5/6 x squared equals 4. So x squared will equal to 24/5. So x is going to be approximately, this is just a little bit greater than 4, so we're going to be around 2.2 for the x-intercept. So I will put that point here. Now to get our third point for our parabola, I'll plug in 1 for x, and we get that that would be 4 minus 5/6, which would be 24/6 minus 5/6, 19/6, going to put us right about here. So I will construct this portion of the graph, and here we are.
Okay, all right, so now we're going to take this second inequality. That's a pretty good inequality, Coach Moret.
It is.
That's at pre-K infant school for mathematics coming out.
No doubt.
So the very first thing we need to do is, once again, we need to find the y-intercept, but we know, so we let all that cancel out. Sort of speed talk, speed math here. So that's going to give us 0.4, which we've already got previously. And then we need to take this going here. We need to find some vertex and the other points on the graph. So we know with the quadratic equation, we can use x equals the opposite of b over 2a. And we're going to speed drill some math, Coach Brett. So you just hang with me and double check. So we got okay, so we know this is A, this is B, that's C. So we've got a opposite of 13/12 divided by 2 of A. So that's going to give me a minus 14/24, correct?
That is correct.
All right, so now we know we have division of fractions, reciprocals, keep, flip, change, keep, change, flip, Kentucky Fried Chicken. So this is really going to be multiplying by 24 over a negative 14. Cancel that out. That gives me 2. So a minus 26 over a minus 14 ends up being a positive 13 over 7. So that's really, if this was 14, it'd give me 2. So we're going to guesstimate 1.9-ish. But so you don't have family disagreements at the supper table over this, and we're going to just let x equals 2 for user-friendly math.
Exactly.
All right, so now with that 2, we're going to plug that back in everywhere we see over here. All right, Coach Brett, here we go again. So minus 7 over 24, and that's 4 because of x squared. 2 squared is 4, so that's 6. We're going to add 13/12 of 2, so that's 6 again, so that's 13/6. Plus 4 is 24/6. So we add all of that up, we get a positive 30 over 6. So the y value would be 5. So our point 2,5 is our other point for this inequality right here.
And I will plot that point Here, now from here, because this is the vertex, I will use that as my axis of symmetry in order to finish constructing out this portion of the conic section, and we end up with this. Now, to complete the coloring activity of this project, we will look at this inequality where y is greater than or equal to 0, which will just allow us to be in the first quadrant here.
Stay in the lines. You remember how they told us, stay in the lines.
Now, we went to the Acme School of Mathematics and not the Acme School of Coloring, so this may not be the prettiest of all red hats, but use your imagination here.
All right. And then we have an idea over here. We got this over here. Now, this is a circle. I'll let Coach Moret and his coloring get out of the way. We got this circle right here. All right, so Coach Moret, we look at, now I always teach my students that anything locked in parentheses, we move opposite.
Exactly.
So this is going to be, if we're looking for, and we know this is a circle just because we know it's a circle, but this is going to be a negative 1/4 here, and this is going to be a positive 4. So that gives us the center of our circle. And then we know that 1/16, that's really r squared here. So we know that the radius is really 1/4 by taking the square root of that. So Coach Moret, if we get a radius of 1/4,
we will have a diameter of 1/2, and we have completed our hat for Santa Claus.
Santa Claus hat. And that's the reason we're doing this right here. So once again, we enjoy doing this. We hope you have a very mathematical, happy Christmas. And
stay tuned for early February when we show you how to use differential equations to predict whether or not Punxsutawney Phil will see his shadow.
That's going to be pretty good. I'm tired, Coach Brett. We're math elites, so we're going to get a drink of Gatorade here. So we wish you a very, very Merry Christmas. Once again, we're the Acme Math guys, Clay Norton.
Alan Moret.
And as Wile E. Coyote said on the Bugs Bunny Roadrunner show, genius.